Hello and welcome to SudoKanard. Here is an arrow Sudoku puzzle that was created by Rainy Rosary for Vietnam's Sudoku Tournament, Round 1, 2022, and it was themed around fireworks like the Thermo Sudoku, which I presented in a former video. And let's have a look at the rules. So if you read Vietnamese, that's awesome. I don't, but I read English and I know the rules anyway. So if you're not familiar with the arrow Sudoku, the rule is that whenever you have a circle, the digit in that circle is the sum of all digits along any arrow that stems from this cell. So this is the sum of those two digits, of those two digits, of those two digits, etc. And for the rest, that's the usual Sudoku rules. It was worth 55 points, which was on the high end of the event, of the round. That was an online contest, but not one of the highest. And if I recall correctly, I did solve this one. As in, I didn't break this one, but not sure. I don't quite remember. So where do we start? There are not so many, so few given digits. So we must focus on the arrows. So this is the sum of those two digits, So we must think of that as a somewhat high number. It couldn't be 1 or 2, obviously. It couldn't be a 3 because it would require those and those to be 1 and 2. It couldn't be a 4 for the same reason, or just because there's a 4 here. It couldn't be a 5 because one of those sets of two cells should have to be 1 and 4 is not available. Couldn't be a 6 for the same reason. One of them would have to be 2 or 4. Couldn't be a 7 or a 9, so that's an 8. And there are 3 options for 8 as the sum of two digits. They are 1, 7, 2, 6, and 3, 5. And you see that all 3 options have to appear somewhere in this box. And obviously, 9 couldn't be a part of them. And 4 couldn't be a part of them because it would have to be 4 plus 4, and that would break the rules of Sudoku. So we get a 4-9 pair here. Now something similar should happen here. So this can't be 1, 2, 3, 4, can't be 5 because of this. Couldn't be 6 for the same reason. One of them would have to be 4 and 2. Couldn't be 7, so it has to be 8 or 9. So could it be 8? No, because 8 would need, one of them would need those to be among 1, 7, 2, 6, and 3, 5. And 2 of those options are eliminated by those given digits. So that has to be 9. 9 has 4 options for the sum of 2 cells, which are 1 and 8, 3 and 6, the one with the 2, the one with the 5. So we know that these 4 digits have to be 1 and 8 somewhere, 3 and 6 in the other position. And now this column 4 has to be here, and 7 has to be here. 7, I say. So that's a start. This 8 says that this can't be an 8, so this can't be a 1. Now this one here says that this can't be a 1 and this can't be an 8. So that's a start. Now let's have a look at this row. So 2 sums equal to 9. None of them has a 5. So 4 can't be on those arrows. 4 can't be here. So 4 is here. And we can't have 7 plus 2 on those arrows because of this 7, so 2 is here. And we can deduce that the missing digits here are 1, 8 somewhere and 3, 6, which means that we have a 1, 3, 6, 8 quadruple in this box. This can be 1, this can be 8. So the remaining digits are, well, because of those 4s, this has to be a 4, this has to be a 5, and we get a 2-7 pair here. That's a nice start. We know that 4 is not on this arrow, so neither is 5. And 5 is not here, so 5 has to be in one of those 2 cells. Knowing that, what are the options for this arrow? It can't be 4 and 5, obviously, but it could still be any of those 2, and it could still be 2 and 7. So I don't think I can deduce more than that for the time being. Oh, this 7 is interesting because now those 2 arrows with a sum of 7 must be 2 or 6, 2 and 6, 3 and 5. This is not a 5, so this is not a 3. That's a quadruple on the column, and this one is not here, so it must be here on the column. And the missing digit on the column must be 9. Because of this and that, and because 9 can't be on the arrow, or this would have to be a 0, we can put a 9 here. And there has to be a 9 up there. Now, what about this? Well, those ones tell us that one of those 2 must be a 1, so that one of those 2 must be a 7. None of them is a 2, so none of them is a 6, but we could have 6 here and 2 there, and 3 and 5 here. So I don't think I can do anything with that information. 1 and 7 here, so this is not 1 plus 7. And this is not a 5, so this has to be 2, 3, or 6, and this is 2, 6, or 5. So there's something going on here. And they could both be 2 and 6, actually. I don't think I can deduce much from that. This 9 now, this can be 1 or 8. So this arrow is not 1 plus 8, it's not 4 plus 5. So the options are 2, 7 and 3, 6. Which is not saying a lot. This 5 now must be somewhere here. And there has to be a 9 in one of those 2 positions. That's not so interesting. Oh, what's more interesting is this 8. This is very disjoint. My way of thinking is very disjoint. Yes, that's the word. So we know that this can't be 1 plus 7 because of this one. So the options here are the same as here. Those are 2, 2 and 6, or 3 and 5. And this can't be 2 or 5, so it has to be 3 or 6. And this must be 2 or 5. But 5 is not available because of this. So this is a 2. This is a 6. And now this is 3, this is 5. This is 2, this is 6. And now those must be 2 and 6. And now 5 is not here, so 5 has to appear somewhere here. Those are a 5, 7 pair. And this is now a 1, 3 pair. That's progress. Well, I guess it's difficult to read. Sorry about that. Now, 7's not here, so we have a 7 in one of those places, and the remaining candidates are 4, 8, and 9. And the interesting part here is that we get 4, 8, 9 triple. So this now is a 3. 3 is removed from this position and 6 is removed from this one. Those here must be a 6 and an 8. Up there, the options are now 4, 7, and 9, but this one can't be a 4. And what now? Is it this? Is it that? Oh, I'm seeing something about this row. It needs to have a 5 somewhere. It will be here or there. 5 here would be with a 3. Why not? 5 here would be with a 4. Why not? So I guess I don't see what to deduce from that. Let's have a look at those rows. This row still needs 3, 4, 8, and 9. Oh, that's a naked single. It has to be a 3. This must be 4 or 8, and this one must be 8 or 9. And now this 3 is interesting because I said just 1 minute ago, there had to be a 5 somewhere here, but 5 here would put a 3 here, which would clash. So 5 goes there, and that's a 4, and it results this 9-4 pair. And this 9 puts a 9 here, which makes this an 8, this a 4, this a 9, this a 7, this a 4, this an 8. And that seems to be all for the time being. But that's something. What about this row? We still need 1, 8, and 9, so this has to be 9. This can't be 9 anymore, that's a 9, and here we get a 1, 8 pair. This 5 now goes here, that's a 7. This 5 removes this option, so 5 goes here. And up there we need a 3 and a 6. I see no elimination. This row now, this column, sorry, needs a 1, a 6, and a 7. So this is 6 or 7. And those are among 1, 6, and 7. So this correspondingly must be 1, 2, or 6. And this must be 1, 2, or 7, sorry. So the remaining digit here can only be a 3. It removes 3 here and 6 there. And 6 was removed by that in the first place. 3 is removed from here and 6 is removed from there, which gives us a 1, 3 pair. So this is not a 1, this is not a 7, this is not a 3, so this is not a 6. This column needs a 2. A 2 here would put a 7 there. And that seems to work. Where should I look? That's pretty confusing. I think something interesting here is that here we have 2 decompositions of 8 as the sum of 2 digits. 9 and 4 wouldn't go in such a decomposition, so this has to be the 3rd decomposition of 8. So if 5 is here, then this is a 3, but 5 wouldn't be here. Could it be 1 and 7? And 1 wouldn't be here, 1 here, 7 there. I think 1 and 7 would be a problem, because then I would have no 7 here, so it would be 3 and 6. And now this would be 1 and 8, and this would repeat the 1. So this can't be 1 and 7. So one option would be 5 and 3. So that would be 1 and 8, that would be 2 and 7, and this would work, I think. And I just said it wouldn't be 1 and 7. That's it. So could it be 2 and 6? With 2 and 6, that's 1 and 8. That's 3 and 7. That's a 5, and it works. Well, that's not revolutionary, so I guess there must be something that breaks somewhere if I... Oh, no. So what can this be? Let's have a look at this last row. Oh no, let's have a look at this row. It must have a 3 somewhere, and 3 is not here, so 3 is here. So that's a 6, that's a 1, that's an 8, and I was searching something much too complicated, too difficult. So that's a 3, that's a 5, that's a 7, so that's a 1, this is now a 6, that's a 2, that's a 7, that's a 1, now this is a 5, that's a 3, and this 3 makes this a 6, this a 3, so that's not a 3, and this is not, no, I was saying that's not a 3, that's a 7, that's a 1, that's an 8, that's a 6, that's a 3, that's a 7, this is a 2, this is a 7, this is a 7, this is a 2, this now has to be a 6, 2, 6, and this 6 now resolve this into an 8, a 6 here, 8 there, 1 and 8, 1 and 2 finally. Alright, so I struggled a little on this latter part of the solve. That's because I was looking for something, for like almost bifurcation actually, where I just had to look for very constrained digits on these rows. So that was very well done by Rainy Rosary and Playmaker, who remixed the puzzle. I'm not sure what it means exactly, but that was really a nice contest and a very nice puzzle in the midst of it. Thanks for watching this video, and see you soon on SudoKanard.